Hello guys, welcome back to my channel and good morning. Today we are going to discuss about this interesting topic regarding force and motion. So this is actually chapter 2 from 4 KSSM. Alright, so without further ado, let's get started. So let's get know a little bit about what is force and what is motion separately first. So force, there are two definitions I give, okay, in my slide. So it is the interaction between two objects. Okay, so it can be it doesn't necessarily between two objects. It can be several objects that interact. Okay, so that's the force. Okay, and this interaction will causes the change in motion. So what does this mean? So imagine if you kick a ball, okay, a football, and then you as a goalkeeper, so you want to block the opponent from making a goal. So you will catch the ball, and then the action of catching the ball actually stops. Okay, stops the ball. So this makes it is changing from moving, okay, because the opponent kicked the ball, so it moves actually, and then you stop it, so it changes from moving to stop. So that's actually you are applying force in order to stop the ball. Okay, other example is when the opponent kick the ball. So the action of kicking the ball is actually applying the force, because you make the football to move or to fly to fly to the goalkeeper. Okay, and then the goalkeeper will catch the ball. So the force is either make something moves, make something accelerates or speeds up, or slows it down, and then finally stop. All right, and then force is actually can be defined as either you push or pull. Okay, as I already tell you just now lah. Okay, so and then what is motion? So motion is actually changing position. So imagine when you're standing at position A and then you walk by at position B, then you are said to be in motion because you change your position, for example from your house to your school. So you are moving. So motion is actually when you move. All right, so I will explain more later on. So this is actually the example of force. So the first one is throwing the tennis ball, as is actually like you are applying a force in order to make the ball to fly in air. Okay, in air. And then the second one is playing a basketball. Okay, so basketball, you
Panggilan untuk penumpang penumpang AirAsia pesawat EK9571 EK9571 ke Tawau. Penumpang-penumpang dipersilakan kepada kelas pintu K20 pintu K20 untuk penerbangan sekarang. Terima kasih. Final call for business morning AirAsia flight EK9571 EK9571 to Tawau. Where all business please proceed partial gate K20 gate K20 for immediate boarding. Thank you.
and then the second one is playing a basketball. So when you throw the ball into the basket, so actually you are applying the force. Okay, your hand applying the force in order to insert the ball into the basket. So it's actually common sense, right? And then when you hit a baseball using bat, actually you so when the baseball is moving towards you, so you hit it. So what happens when you hit the baseball using the bat? So the baseball will change its direction. So that's the characteristic of the implication of applying the force. So it will changes the direction. Okay, and then B, so magnetic force. So magnetic force is due to magnetic field. So I will not explain so much about that, but I just want you to know that the magnet will usually attract metals, or mostly steels. Okay, steel, it will iron. So mostly it will attract some metals. Okay, especially iron. Okay, and I want you to know that when you interact two magnets of the same pole, so they will repel. Okay, the same pole, south and south, and also north with north. Okay, so for different poles, south and north, for example, they will attract with each other. So that's the basic of the magnetic force. It is due to the magnetic field. And then example E is pushing a trolley, F is playing a football. So when you kick the ball, okay, you will make the ball to move towards the direction of your kicking the ball. And then moving a car, and then falling apple. So falling apple is due to gravitational force, alright? So gravitational force. So this is about displacement, distance, and speed. Okay, and also velocity, acceleration. I will not read this, but I will explain you using my sketching. I will explain to you like this. Okay, so for example, so what is displacement? So displacement is actually, if you read my previous note, it is final position minus initial position. So just imagine if you have your house over here. So this is your house. Okay, so this is your house, point A, and then your girlfriend house over here, so point B, your girlfriend. And then this is your school. Okay, your school, like this lah. Okay, so this is your school, a little bit bigger. Okay, so this is your school. All right, so when you move, displacement is okay, so you move from point A to your girlfriend house. Okay, so the distance is about, I don't know, can you give me number? Oops, wait. For example, 5 kilometer, and then so this is school, and then from your girlfriend house to the school is basically 7 km. So you walk from A to B, your girlfriend house, and then to school. So displacement is actually considering only from the final minus the initial position. So where's your initial position first? So your initial position is this lah. So this is your starting point or initial, and then your final position is here. So displacement is from end to start, or from start to end. So it's the same lah. Okay, so it's from here to here. So for example, the distance is, I don't know, well, probably 6 km. Okay, so this is displacement. So your displacement is 6 km. So that's displacement. So displacement is final position minus initial position, like that. So from final point to the starting point. Okay, so it's very easy. But for distance, it's just the total distance you travel. So you travel from your home to your girlfriend house, and then to the school. So total is 5 plus 7. So your distance is actually from A to B is 5 km. From B to school, your girlfriend house to school is 7 km. So this is actually 12 km lah. So this is distance. So they are different. Okay, so for displacement, it is a vector. It is a vector. And for distance, it is a scalar. So it has no direction. So if you realize the black line I draw, I indicate the arrow, which means it is a vector. Okay, but for the red line just now, oops, I already, so this is displacement because I draw the arrow. But for distance, I don't draw the arrow, the vector arrow, because it is scalar, so it has no direction, like that. Okay, so that's the difference. Okay, oops. Okay, what about speed? What is speed? Oops. Speed. So speed and velocity has the same magnitude, but the difference is the former one, speed has no direction. So this is only magnitude. Magnitude is a value lah, but no direction. No direction. So it is a scalar. But for velocity, okay, the magnitude is same with the speed. So magnitude plus direction, which is a vector. So that's all. Okay. Okay, so they have the same value or the same magnitude. For example, if I say the speed of the car, so this is a car. For example, this is a car. Okay. So the speed of the car moving forward is v equals to 30 kilometer per hours. So this is the speed or the velocity, and then okay, so this is the velocity, not the speed, sorry. So if velocity, you need to include the direction forward lah, okay, or to the right. But for speed, I indicated by s, speed like this. I don't want to make you confused by using s, because s is in physics it is displacement usually. So the speed is actually 30 km per hour too, but I don't put the bracket like this to indicate the direction, because we don't have to, because it is a scalar. So like that. Okay, so they have the same value, but for velocity it has additional description, which is the direction. So that's how we differentiate. And then what is speed and velocity in terms of magnitude? Okay, so speed is basically when you have a change in position over time. Change in position over time. For example, I'm using the similar example. So this is your house A, so position A, and then you move to your girlfriend house in straight line. Okay, so this is your girlfriend house B. Okay, so when you change from A to B, actually you are moving, right? Of course, when you move, you have certain kind of velocity or a speed. Okay, but what makes you move faster and what makes you move slower is the time, t. How much time you takes, t. So that's why, that's what velocity. For example, if you for example, the distance is just now is how much I give, 5 kilometer, right? So this is 5 kilometer from your house to your girlfriend's house, 5 kilometer. So when you move, if you take, for example, 5 kilometer, you walk, you took 30 minutes. Okay, and then T1, T2 is you took, for example, longer, 50 minutes. So which one is faster? So of course, the time taken, the time it took shorter, right, which is T1. So this is faster, because it only take 30 minutes rather than 50 minutes, which is longer. So this is faster and this is slower. Okay, so that's why the formula for speed or velocity in terms of magnitude, so I just use V, is actually distance, displacement, or S. Okay, so displacement in physics we indicated as S divided by T. So S here is 5 km. So because final minus initial, which is 5 km, divided by, for example, I use T1 first, 30 minutes. Okay, so 30 minutes is, I convert into hour, so it is half hour lah. So this is 10 kilometer per hour. Okay, so this is V1. So for V2, when you travels for 50 minutes, let's see what's the velocity. So S is the same lah, 5 km. 50 minutes is 5/6 hours. So this is 6 kilometer per hour. So which one is faster? Of course 10 kilometer per hours, right? Oops, 10 kilometer per hours. 10. So of course this one is faster, 10 kilometer per hours than the 6 kilometer, right? So that's why when you travel shorter time, you are more faster than the when you travel in the longer time. So that's what velocity means, when you have change in position over time. Okay, so you need to include over time, not change in position only, like that. Okay, so we are going to discuss about linear motion. All right, so this is interesting. So linear motion is when you have a constant velocity. Okay, so just keep in mind that it is just a constant velocity stuff. So constant velocity. Okay, constant velocity. Oops. All right. And when you have constant velocity, it's actually you don't have any acceleration, because constant velocity means oh yeah, I forgot to explain what is acceleration. All right, sorry for that. All right, so let me add over here. I will explain what is acceleration means. So acceleration, so apologize because I forgot to explain about this. So acceleration, so if velocity is a change in position or change in displacement over time, so acceleration is actually change in velocity over time. Okay, so for example, I'm using the car example. So this is a bus or a car, you can say. So sorry for the bad drawing. So when it moves forward at v equals to maybe 30 kilometer per hour. So this is at t equals to maybe I can set it as t equals to 0 first. So initially it is moving at v equals to 30. So this is before, and then after that it accelerates. Okay, it accelerates, so it more faster. So I draw the vector length to be longer than the first one. So v equals to maybe 60 kilometer per hours. This is at t equals to 3. So you see there is a change in time, and also there is a change in velocity. So when this bus travels, when this bus changing its velocity at certain time, so we define the bus to be accelerating, which means it is getting faster. This is accelerating. Oops, sorry for that. Wasted. So it is actually accelerating. Accelerating. Oops. Oh, sorry. So it is accelerating. So accelerating is basically it is getting faster. So that I guess you already know what accelerate mean, getting faster. So that's why the formula for acceleration A is actually change in velocity, which is v final minus v initial minus change in time. So t final minus t initial. So let's calculate the change in velocity over time, or acceleration. So which is 60. So this is after and before lah. So after is 60 minus 30 kilometer per hour. So time taken is 3 minus 0, which is 3 seconds. Okay, So the acceleration is 60 minus 30 divided by 3, 10 kilometer per hour per second. So okay, so because this is just a demonstration to give you a better picture of acceleration, I just leave the unit like this. But actually you can actually change this second into hours so that the unit is uniform. So you will have something like kilometer per hours instead of kilometer per hour per second. So this is not it is, but you can leave it like this. Actually it has it's not a problem actually, but for just for consistency, okay, I prefer to change it into 1 unit of time, okay, instead of 2 like this. All right, so that's just formalism. All right, okay, then we move on to the a this subtopic. So linear motion. Oops. So linear motion is actually when you have a particle move in the straight line. So it can be a uniform or non-uniform. So non-uniform means the velocity changes, which means the acceleration is not zero. There is acceleration, like in our previous case just now. Okay, when we are talking about uniform velocity, the velocity is constant, which means along the way, okay, the velocity doesn't change because it is constant, right? So the definition for constant is doesn't change. So when the velocity doesn't change, okay, it has no acceleration, right? It is not accelerating. Can you catch that? All right, so as you can see, this is the graph of a constant velocity. As you can see in the first graph, so this is constant velocity, which means the velocity doesn't increase or doesn't decrease. So it is constant, which means it doesn't change. So remember the definition for acceleration, it has to be some changes in velocity, then you will have a acceleration like that. Okay, so but for non-uniform you have a changing velocity. For non-uniform you have changing velocity, which means you have a acceleration. Acceleration is not zero in this case. Hence the graph will be a straight line like this. Okay, straight line like this instead of a flat line like the previous one. So this is a flat line. Okay, so you need to take a better look on the axis. So this is velocity against time, so it is a straight line. But for acceleration against time, it is a flat line, so it depends on the axis. Okay, for a non-uniform or changing velocity, okay, there is acceleration, but the acceleration is constant. You need to remember that acceleration is constant. Any graph that you see, if it is talking about constant, the graph always like this. It is a flat line like this. So this is actually a constant graph, we say. For example, it is a y and x axis. Okay, so that's why for a constant velocity, the velocity against time graph is look like this, a flat line. Okay, and the right side over here is the kinematics equation, which you need to understand and also memorize at least. So I just want you to take a look on this first equation, v equals to u plus at. Okay, so what is u, what is v, what is t? It is indicated here. You can read. U is final, u is initial, and v is final velocity. T is as usual time, a is acceleration. I guess you already know this. And then the second equation is s. S is displacement. Change in displacement. Okay, change in displacement. So I want you to rememorize all of this equation lah. Equation 1, equation 2, 4 equations you need to remember. Okay, so I will skip this. Okay, but you can try to do it. You can pause the video and try to do. Alright, so this is the answer. So I will explain more in the next video. I want just to focus on the material about this. All right. Okay. Let's talk about ticker tab and ticker timer. So ticker tab is ticker tab and ticker timer is actually apparatus to measure velocity and also acceleration of the moving car. I mean, as a toy car lah in this case. Okay. So how it works is by the ticker tab timer actually vibrates. So it will vibrates at certain frequency, but usually in your textbook it is indicated as frequency 50 hertz. So as you know that frequency is actually f. Okay, frequency is f, and f is 1 over s. 1 over t. Sorry, it's f equals to 1 over t. Sorry for that. So it is f is to 1 over t. So it is the reciprocal of time. So because it is 50 hertz, so time is actually 1 over f, which is 1 over 50 second. 1 over 50 second is about 0.02 second. Okay, so that's the time for one tick. But what is one tick defined? Okay, one tick is defined as the gap between this. So the gap between first point and second point is basically one tick. Okay, and then the next one is the second tick. So this is first tick lah, first tick, second tick, third tick, and next, and so on, right? Okay, how to know the starting point? So the starting point, which means which one is the starting point? Is this or is that? So in order to know the starting point it is very easy. Oops, wait. I just moved the. Okay, like that. So the starting point, you just take a look on the head of the arrow. So this is the head of the arrow, right? So the starting point is pointed by the head of the arrow, which is here. So it starts here, and then the ending is of course here. So you just see the head of the arrow, and then you can know the starting point. And for the first case, this first diagram, so the starting point is here because the arrow is indicated to the right. So the starting point is to the right. Sorry, not ending, starting. So the starting point is here, and then the ending is here. Okay. So what about the third diagram? Where is the starting point? I will give you 3 seconds to guess or to answer. Alright, so the starting point is here, start, and this is the ending point. Why? Because the arrow indicated to the right. Alright, so let's see this simulation. So you can visit this website if you want, and let's see. So can I access this? Okay, unfortunately I can't.
Panggilan audio untuk penumpang-penumpang Airlines pesawat Z9893 Z9893 ke Tawau. Penumpang-penumpang
Okay,
silakan
so we visit this website first. Let's see.
Pintu J15.
So this is the simulation.
Terima kasih.
Okay, 50 hertz.
Final call.
So let's try to measure. So you can see the starting point is here. As you can see, there is like a pan which is vibrating. So this is actually the ticker tab. Sorry, the ticker timer. So it vibrates. So it is the tip of the ticker timer. So it vibrates. As you can see, it vibrates at a frequency of 50 hertz. So let's measure. Let's run first. Oops. So let's reset. So as you can see, so the motion is towards the the motion is towards the bottom of this inclined plane, or it is downwards direction. So you can see the direction downwards, which means the arrow is towards the downwards direction. So the starting point is of course to be over here lah, okay, near the blue toy car over here. So this is the starting point, which is where the direction of motion pointing to, okay, and then the ending point is here. Oops, where is it? My oops. Okay, so the ending point is over here lah. So this is the ending point. Okay, this is the ending point. This is the starting near the toy car, okay, here, and then this is the ending, like that. Okay, so yeah, that's verify our my explanation just now. Okay, done. Okay, so let's take a look on this. Okay, so constant velocity if the tick has a uniform separation distance. So you can see over here, so the direction of motion is towards the right, which means that this is the starting S, okay, and this is the ending. Okay, so when you see the starting point, I mean not the starting point, the separation point, a separation distance is about similar. For example, this is 4 cm, this is 4 cm all the way until this. So if the separation distance is same or uniform, which means that the object or the moving object has constant velocity. But for increasing and decreasing velocity, the distance or the separation distance of the tick is not uniform. Okay, so for increasing, because the starting point is over here, start, okay, see this head, and then this is the ending. So you can see this is our starting point. So from here, so it is shorter distance, and then it is getting longer and longer towards here, towards the ending point. Okay, so if the separation distance increases, which means the velocity increases lah, which means the velocity acceleration is positive. Acceleration positive. And for decreasing velocity, this is a different case, or the this is opposite to the decreasing velocity case, where the distance between the dot or the tick distance is getting decreases instead. Okay, so of course the direction of motion is from here, start, and this is the ending. So you can see the distance decreases, so from this length to this length at the end, so from longer to shorter, which is decreasing velocity. All right, so for decreasing velocity, the acceleration is instead to be negative. Okay, so what does the negative acceleration tells you? Acceleration negative, it means that it is a deceleration, so it decelerates or getting slower. Okay, like that. Alright, so you can read this a little bit. So for constant velocity, it has a uniform separation. So closer dot indicate low velocity and farther dot indicates high speed. So as I discussed just now lah. So this is closer dot or a closer tick. So this is slower. Okay, slower speed. Okay, as it is indicated here. Okay, so for C, because the distance or the length between the point or the tick point, the tick distance is the longest, so it has a higher or the highest velocity or speed. All right, like that. But for the calculation is quite easy, because you just use the formula that we already discussed, which is V equals to displacement S divided by T. Okay, So average, we are talking about the average velocity. So for a constant uniform motion, so the velocity, the acceleration is 0. So it has no acceleration. So how you calculate the v? So v is actually the total distance lah, s. So the total distance is from the the ending, from the ending minus the initial point. Okay, so this is the starting and this is the ending. So the total distance or the displacement is from here to there. Okay, so it is 24 cm, and then the time, because it altogether is 6 tick. So 6 tick is how many seconds? So 1 tick we know. Okay, so this is for 50 hertz ticker tape. Ticker timer, which is 0.02 second. So this is the this is the frequency of the ticker timer. Okay, so 1 tick is 0.02 second. So 6 tick is you just multiply by 6 lah, 6 times 0.02, which is 6 times 0. Which is 0.12 second. So you just divide 24 with the 0.12 second, you will get 200 centimeter per second. Okay, it's very easy. Okay, so similar with this, even though it is a changing velocity with acceleration not 0, similar application, the total displacement, which is 35, you divide with the total time, which is 7 ticks. 7 ticks you convert into second lah first. So 7 ticks is 7 times 0.02 second. When you divide them, you will get this answer. Alright? Okay, so what about calculating the acceleration? So when you have acceleration, it is actually the changing or the change of velocity over time, right? Okay, it is similar. You just apply the formula. So A equals to V final minus V initial over total time. Okay, so the first I want to calculate the V final. So V final, first you need to determine which one is the starting point and which one is the ending point. So the starting point, of course, here. Sorry, that's the end. Starting point is here. So start. Ending is here. So the ending point. Okay, so we calculate the separation distance at the end, which is 1 cm. Okay, and then because it is only between final point and then the second final point, which is actually 1 ticks difference. So 1 ticks is 0.02 second lah. And then you just divide 1 divided by 0.02 second, you get like this. Okay, 50 centimeter per second. And then you do the same thing with the starting point or the initial point. Okay, 40 cm divided by 1 tick, because it is between this and this. Okay, 0.02 second. Why 0.02 second? Because we are considering 50 hertz ticker timer, like that. Okay, finally you get this answer, 700 cm per second. Okay, so what you do with this value? So you just apply the formula for this. A equals to V final minus VI, V initial divided by total time. So V final is 700, not 70, 700 cm per second, and V initial is 50. What is the total time? So total time is, because we need to consider all together, okay, because it is total. So all together is 7 ticks, but 7 ticks you need to convert into second. So 1 ticks is 0.02 second, 7 ticks is 7, you multiply with the 0.02, and then you just divide this value, you will get this. Alright, 4,642 0.86 centimeter per second square, like that. Okay, so I hope you understand. Okay, let's talk about what if you are given graphical form. So it is actually not so hard actually. So when you are given a graphical form, one thing you need to notice is if it is like this, the ending point you can the end of the ending point, yeah, the ending point. If you connect the ending point of these strips, okay, the different there are 5 strips, you connect the ending point. If it is forming a straight line, which means it is a uniform acceleration or constant acceleration. Constant acceleration means the velocity is changing uniformly. Okay, uniformly. Okay, so this is the second case is uniform deceleration. Deceleration means the body or the moving object decelerate or decreasing in velocity. Okay, the velocity changes. The velocity changes. Changes. How to say? Deceleration is a decrease in velocity basically, but the decrease is actually uniform. So that's why you have a uniform deceleration. So how we want to calculate the acceleration and also the deceleration. So it is same concept. So we are using same formula, Vf minus Vi divided by total time, this one. First you need to find Vf and Vi. So Vf is the final position divided by time. Okay, so you need to identify which one is the final position and which one is the initial position. So the final position is the last strip. This is the last strip or the last ticker tab. So this is SF. So you are reading this graph from left to right, not the other way around, right? So the initial strip or the initial ticker tab is this part. So you are considering that part only. Then you just calculate. Okay. First is I want to start from the SI or the initial position. So initial position you can read from the graph. It is 2 cm. Okay, the length is 2 cm. Time. So how many ticks? So you can measure. There are 1, 2, 3, 4, 5. 5 gaps. 5 gaps means 5 ticks. Okay, so each tick is 0.02 second. So 5 ticks is 0.02 times 5. Okay, so just divide 2 divided by this value, you will get 20 centimeter per second. And then you do the same thing with the Vf. So the total length from the top to the bottom is 10. So you just read from the graph, it is about 10 cm. Total time is also 5 ticks lah. So 1, 2, 3, 4, 5 ticks. Okay, you get this answer, 100 cm per second. And then using that you can find acceleration. So Vf is 100, Vi is 20. So 100 minus 20 is 80. Okay, and then you need to divide with the total time, because each strips has 5 ticks. So 5 you plus 5, 5, 5, 5. So together is 30, right? 30 is it? 30 ticks. So 30 ticks you times with the 0.02 second. You get this acceleration to be 133.33 centimeter per second square. Okay, so you do the same thing with the uniform deceleration. Okay, remember that this is the initial position or initial initial. Oh, sorry. Initial. And then this is final. Okay. So you do the same thing, find the VF and VI, and then you subtract them. So you get 60 minus 100, which is minus 40. Okay, minus 40? Yeah. And then you divide with the 50 times 0.02. Why? Because the total ticks over here from the first, second, third, fourth, fifth strips altogether is 50 ticks. Okay, because 10 plus 10 plus 10 plus 10 plus 10 is 50 ticks. 50 times 0.02 second. Okay, which is basically 0.1, is it? So let me recalculate if I did any mistake. So 60 minus 100 is minus 40 divided by 50 times 0.02. Yeah, it's minus 40 centimeters square. So why minus? Okay, because minus the minus sign for acceleration means, usually means deceleration. Okay. So this is usually means deceleration, but in this case it is deceleration. But actually sometimes minus acceleration can be associated with the direction, not because it is decelerating. Okay, so that's another topic to be discussed. Actually, I will not touch about that. Okay, and for the non-uniform acceleration, because the textbook doesn't cover that, I will not discuss about this. All right. Okay, so let's move into the linear motion graph. So you need to get used with this graph. So you have a flat graph like this, and then you have a straight line like this. So it is not flat, but it is a straight line. And then you have a curve. So a curve in number 1 is what you usually encounter in this topic rather than the graph number 2. Alright, and for diagram D, you will usually encounter this graph number 4 rather than the graph number 3 in this chapter. So I want you to focus that one lah. Alright. So I want you to take a look with this diagram first, second, and third. Okay. So the first column is ST graph, we call ST graph, and this is VT graph, and then the last one is the AT graph. Okay, so for ST graph, when you have a flat line like this, actually you can transform it into VT graph. So this is transformation of graph lah. So from ST you transform into VT. So when you transform a graph, flat line for the ST graph, you will have something like this. Okay, why? Because for a flat line in ST graph, it indicates that the particle or the object is not moving, because over time, at time this t equals to 0 to time t equals to t, it is at the same position at s equals to 10. Oops. Right. So it doesn't change in position. So when there is no change in position, which means it doesn't move. Okay, remember the definition for displacement is final minus initial position. So when the final and the initial is the same, which means it doesn't move. So when it doesn't move, which means that the velocity is 0. Okay, so if the velocity is 0, it doesn't move, which means that the velocity, the acceleration is also 0 over here. Okay, so we can transform from from ST, transform to VT, and then transform to AT like that. Okay, the second row, we start from ST graph, we want to transform to VT graph. So when you have a straight line like this, just remember, when you have a straight line like this or like this, a straight line moving upwards and moving downwards, you will usually have the VT graph to be like a flat line like this, so when you transform. Okay, but for ST graph, the straight line of moving upwards, indicating that the constant velocity in forward direction, and when for the straight line moving downwards, it is actually in reverse direction instead, but both are in constant velocity. Why? Because if you see the graph, the graph actually, the position actually changes uniformly. Okay, the gradient is unchanged. So when the gradient unchanged, because the definition for velocity is actually change in s divided by change in t. So the triangle here is basically means change in. So the triangle symbol is it means change in. So when the change in s divided by change in t, it produces a gradient. So the gradient is same along this line, point of the line. Okay, which means that the velocity is constant because the gradient is similar along this line. Okay, like that. Oops. So, but how we are going to change into AT graph? So if you have a straight line like this, a flat line like this. So remember, previously we have a flat line like this. We transform, it becomes 0 for VT graph. So similarly, for VT graph, if you have flat line like this, you transform into an AT graph, it will be like this. So the acceleration is 0, because it is constant. Remember, constant acceleration, constant velocity has 0 acceleration. Okay, and then the last row, the third row. Oops. Okay. So when you have a curve like this in ST graph, so you have a curve like this. So how you want to change it into a VT graph? So basically, when you have a curve like this, okay, usually we change it into another axis. In this case, is a VT axis. It will form a straight line. Okay, straight line like that. So from a curve, you transform, it will form a straight line. And from a straight line, you want to transform into another axis. Remember that previously, when you have a straight line, you want to transform into another axis, it will be a flat line. So this is actually a flat line. Okay, and then this is a straight line. You change into another axis. Okay, it will form a flat line like this. Alright? Oops, sorry. Pardon me. Flat line like that. Okay, so that's actually my way of, not understanding, my way to remember how to change or to transform the graph of another axis to other axis. Correct? So this is just a tips that you can take a look, a glance look. So I will explain a little bit about this. So when you have, we start from the ST graph first. ST graph, and then ST graph, and then VT graph, and then AT graph. Okay, so for ST graph, okay, the gradient for the ST graph, so what these tips means is the gradient of the ST graph, oops, sorry for that. oops, where is it? The gradient for the ST graph will produce a VT graph. Okay, and then the gradient for the VT graph will produce a acceleration AT graph. So that's how the my tips works. And when we move in the reverse direction from AT, VT to ST, okay, the area of the AT graph will produce a VT graph, and then the area for the ST graph will, the area of the VT graph will produce a ST graph. Okay. Alright, so I think that's all for my video. So I need to end now because it's yeah, I think that's all for my video. Thank you. Yeah, I think I need to stop in this part because due to a lot of commotion here. So yeah, I need to stop, and yeah, thank you for your cooperation and your attention.